Welcome back to another exciting adventure of Mr. Warnow Does Your Homework. Alright, in this video we are going to continue reviewing Taylor series, getting ready for our test and everything. So we have a few questions. We'll go over a few of the questions from your homework. This is number 1, and it asks, which of the following is a term in the Taylor series about x equals 0? So we know this is Maclaurin. For the function f of x equals cosine of 2x. And they give us a bunch of choices right over here. Now this question right here you don't have to know this straight out. I mean, you could try, I'm going to generate the Taylor series using the old derivative way. But because we know it's Maclaurin, we know we could use the shortcut. So I'm just going to generate the Taylor series for cosine of 2x. And to do that, we know that cosine of x, remember cosine is an even function, so this is our 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial plus minus x to the 6 over 6 factorial, and so on and so forth. It goes on forever. And I replace every x here with 2x. And if we do that, that becomes 1 minus, this becomes 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial plus dot dot dot. And of course, if you clean this up, we get 1 minus, what's that, 4x squared over 2 factorial plus, what is that going to become? 2 to the 4th, which is 16x to the 4th over 4 factorial minus 2 to the 6th is 64x to the 6 over 6 factorial. And notice down here, we don't normally simplify, but here they did. So if I were to reduce this, this becomes 1 minus x squared, 2x squared, plus, remember this is 24, so that becomes 2/3 x to the 4th minus, and 6 factorial is 720. So this becomes, if you reduce it, 4 over 45 x to the 6 plus dot dot dot. And which one does it match up with? Oh man, it looks like it might be this one, but the wrong sign. So we got to be careful of the signs because they alternate. So let's see here. Let's see, x to the 2/3. Up there it is. X to the 2/3 x to the 4th. So the answer is C. So those two match up right there. All right, be careful of the signs; they do alternate. All right, so for question number 3, it says, the series here is the Maclaurin series for which of the following. So they just want to see if you can recognize it. And right away, I can start looking at this and say, you know, it kind of looks like e to the x. This is x plus x cubed over 1 factorial plus x to the 5th over 2 factorial plus x to the 7th over 3 factorial. Well, I recall that e to the x is just 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus like x to the 4th over 4 factorial, and so on and so forth. So what I have to do is kind of figure out, well, what did they do here to make this equal to it? So I'm thinking e to the x, so I'm probably thinking it's not a or b right there because those are natural logs. So the first thing I notice is each of the e to the x's has this e to the x squared. So I'm going to go ahead and apply that rule, e to the x squared here. Remember, anywhere there's an x, I'm going to replace it with x squared. So this becomes x squared plus x squared squared over 2 factorial plus x squared cubed over 3 factorial plus x squared to the 4th over 4 factorial, and dot dot dot. And if I clean that up, 1 plus x squared plus, that becomes x to the 4th over 2 factorial plus, this becomes x to the 6th over 3 factorial plus x to the 8th over 4 factorial, and so on and so forth. So now I need to think, well, okay, so this is if I replace it with x squared. So clearly it's just not e to the x squared, because otherwise they would look the same. So let's see here. So my two choices are I can either multiply by x now or multiply by x squared. So let's see here. I want to go from a degree of 0 to a degree of 1, a degree of 2 to a degree of 3. So I'm just multiplying by x. So, and if we can easily see that, if we did x e to the x squared, we're just multiplying everything by x. X plus x cubed plus x to the 5th over 2 factorial plus x to the 7th over 3 factorial. And it does become the exact same answer right up there. Alright, very good. So number 5, now when you take the AP, they're going to give you all the space on multiple choice. It's crazy how much space they give you. Alright, so for number 5, this is a tricky one right here. This is the one that always, I think, gets students the most. It says, let f of x equal this summation. Now remember, this is an infinite sum. That's going to come back in just a second here. We'll see. We want to evaluate the value at 2 pi over 3. So we want f of 2 pi over 3. And I'm going to plug that in. N equals 1 to infinity. That should be cosine 2 pi over 3 to the 3n. Cleaning this up, well, what is the cosine of 2 pi over 3 but negative 1/2? So we get this. Negative 1/2 to the 3n. I'm starting to think this looks geometric, but remember, geometric has to be r to the n, right? Or r to the n minus 1, so I'm going to get rid of that 3 here and distribute that in. We get n equals 1 to infinity, negative 1 over 8 to the n. So again, I'm thinking this is a geometric series right here. And I know how to find the sum of a geometric series. And that is just a sub 1 over 1 minus r. So it's our first term, and I can get my first term by plugging in 1 here, and that's just going to give us negative 1/8 over 1 minus, and my r is just negative 1/8, so plus 1/8. And I'm lazy, I'm just going to multiply everything by 8, top and bottom. And I'm going to get negative 1 over 8 plus 1, so we get negative 1 over 9. I like the GCF, quick way to get rid of those things. Alright, we're going to stop this video right here, very short, but go on to the next video and we're going to take a look at a couple more questions from your homework. See you then.